Okay, so question number 3. What is the Lewis structure of ethyl alcohol? C2H5OH. So when drawing the Lewis structure, we first need to calculate the total number of valence electrons for this molecule. So carbon has 4 valence electrons, and we have 2 atoms of carbon, so we multiply this by 2. Hydrogen has 1 valence electron, and in total for this molecule we have 6 hydrogens. And then lastly, oxygen has 6 valence electrons. So adding these values up, we have a total of 20 electrons for this Lewis structure. So now if we try to draw a skeletal structure for ethyl alcohol, we can show that one carbon can be bonded to another carbon, and we can draw 3 hydrogens out of the 5 or out of the 6 on the first one, and show how the oxygen is bonded to the second one. And now we just need to fill in all of the remaining hydrogens like so. And if we count out how many electrons I've drawn so far, recalling that each bond contains 2 bonding electrons, we have 16 out of the 20 electrons drawn in this structure. So for the remaining 4 electrons, I can put them as lone pairs on my oxygens. So now I have the correct Lewis structure for ethyl alcohol. And notice that when we named ethyl alcohol, since we have a 2-carbon chain, we would use the prefix ethyl, and the alcohol group can only be on carbon 1, like even if it was on the second carbon, it would also be considered carbon 1. So then we just put ethyl alcohol, or we can also call it ethanol, which is the same name. Okay, so the junior tutor said that the Lewis structure of a molecule is the easiest way to represent a molecule with different electron pairs. Electron pairs may be in the form of bonds or lone pairs, and lone pairs are pairs of valence electrons that are unshared and usually represented as pairs of dots surrounding an element. On the other hand, bonds are represented as a line connecting 2 atoms. To properly draw the Lewis structure of a compound, we follow the steps below. Step 1, find the total number of valence electrons. So this is done by adding all the valence electrons from the atoms. And step 2, we find the number of electrons needed to make the atoms follow the octet rule. Elements up to period 4 on the periodic table need to follow this rule except for hydrogen. In addition, elements from period 5 can have an expanded octet. Step 3 is to determine the number of bonds in the molecule. This can be done using the formula step 2 minus step 1 divided by 2. Then we choose the central atom. So usually it's the least electronegative or the one with the highest valence electrons. So in our case, carbon isn't the least electronegative, it's actually hydrogen. So the fact that it can form multiple bonds is the reason why we made carbon our central atom. Step 5 is to draw a skeletal structure, and step 6 is to place electrons around the outside atoms, and step 7 is to place any remaining electrons around the central atom. Okay, so they got the correct Lewis structure, so this solution is correct.